This story is written and narrated to honor the forgotten brilliance of Chien-Shiung Wu, a woman whose mind bent the very laws of nature, yet whose name was almost erased from the fame she helped create. Based on true events from the golden age of physics, an era ruled by men in white coats and silent laboratories, this story follows the extraordinary journey of a young girl from China who rose above prejudice, exile, and invisibility to become one of the greatest experimental physicists in history. Known today as the First Lady of Physics, Chien-Shiung Wu proved that even the unshakable laws of the universe could be rewritten, showing the world that genius knows no gender, no border, and no silence. The year was 1912, a quiet morning in the village of Liuhe, China. The world was shifting, nations rising and falling, but in one small house, a child was born who would one day make the universe itself question its rules. Her name was Chien-Shiung Wu. Her father, a revolutionary thinker, believed that girls deserved education just as much as boys, a radical belief in a world where women's dreams were locked behind walls. He built a school where girls could learn science, mathematics, and philosophy, and it was there that young Wu's fascination with the universe began. She wasn't just curious, she was relentless. She looked at the stars not with wonder, but with determination, as if daring them to reveal their secrets. By the time she was a teenager, she had read every science book she could find, solving equations far beyond her age, her mind sharper than any blade. But for a girl in early 20th century China, the path to science was not paved with encouragement, it was carved out of defiance. At 24, she left her homeland with little more than her notebooks and unshakable resolve. Crossing the Pacific Ocean to study in America, she arrived in California in 1936, a stranger in a foreign land, facing the storm of racism, sexism, and isolation. But she didn't come to fit in, she came to understand the universe. At the University of California, Berkeley, she entered the world of atomic physics, a field dominated by towering male figures like Ernest Lawrence and Robert Oppenheimer. In those echoing halls where ambition and ego collided daily, Wu stood quietly at the edge of greatness, and then surpassed it. Her experiments were flawless, her intuition razor-sharp. She could see what others couldn't. The rhythm hidden beneath chaos, the truth buried beneath assumptions. Soon her peers whispered about her precision, her relentless patience, and her uncanny ability to make the invisible visible. Then came World War II. The same institutions that once doubted her now sought her genius. Wu was recruited to the Manhattan Project, the top-secret mission to build the atomic bomb, not as a face in front of cameras, but as a silent force behind equations and machinery. In the shadowed labs of Los Alamos, she perfected methods of uranium enrichment and detection that would change the course of history. But when victory came, her name was absent from the records. Men took the credit. Wu returned to her lab in silence. She had helped end a world war, but history barely noticed. Yet her greatest discovery, the one that would shake the foundations of modern physics, was still to come. In 1956, two theorists, Tsung-Dao Lee and Chen-Ning Yang, came to her with a bold question. What if one of physics' most sacred principles, the law of parity, which stated that nature treated left and right equally, was wrong? For half a century, scientists believed the universe was symmetrical, that its mirror image would always behave the same. But Li and Yang had doubts. They had a theory, but they needed proof. And there was only one person brilliant enough to test it, Chien-Shiung Wu. In the icy winter of 1956, in the underground laboratories of Columbia University, Wu began an experiment that would change the very way we understand the universe. She worked for months, often through the night, her breath freezing in the air, her hands steady as she cooled radioactive cobalt to nearly absolute zero. Surrounded by machines that hummed like living things, she aligned the atoms, watched their decay, and waited for the universe to speak. And then, it did. The results were unmistakable. Nature itself had a preference. The mirror world was not identical. The universe could tell left from right. The law of parity was broken. It was one of the most shocking discoveries in the history of physics, a revelation that rewrote textbooks and redefined reality. The scientific world erupted in awe and disbelief. Wu had proven that even the most sacred rules of science could be wrong. But when the Nobel Prize was announced the following year, it was awarded to Li and Yang, the theorists who had asked the question, not to the woman who had answered it. Wu's name was missing once again. The newspapers called her the woman who should have won the Nobel. But she never complained. When asked how she felt, she simply said, "I have done my work. That is all that matters." But it did matter. It mattered to every girl told she didn't belong in a lab. It mattered to every scientist whose work was dismissed because of who they were. Wu became more than a physicist. She became a symbol of defiance, of brilliance that refused to be silenced. She mentored young women, spoke out against discrimination, and reminded the world that the pursuit of truth was bigger than any prize. Her students described her as fierce, yet kind, a woman who demanded precision but inspired greatness. They began to call her the First Lady of Physics. But Wu never sought titles. She cared only for discovery. After the parity experiment, she continued her research, exploring beta decay, nuclear structure, and the hidden symmetries of the cosmos. Her work shaped generations of scientists and laid the foundation for quantum physics as we know it. Even Einstein's theories were influenced by the kind of questions she dared to ask. In her later years, Wu finally began receiving recognition, honorary doctorates, medals, and global awards. Yet even then, she remained humble. When someone once asked if she was bitter about being overlooked by the Nobel Committee, she smiled gently and replied, "There is only one thing worse than facing an impossible problem, believing it cannot be solved." Her words became her legacy, a message to every dreamer who faces doubt, to every voice drowned out by the noise of history. She proved that true genius is not about glory, it's about perseverance. As her hair turned silver, Wu returned often to China, visiting schools filled with girls who now studied science because she had once dared to. To them, she wasn't just a scientist. She was living proof that greatness can rise from anywhere. When she passed away in 1997, the world finally paused to remember the woman who had redefined physics, shattered barriers, and humbled the universe itself. Today, every time a physicist studies the weak force, every time a student learns that symmetry can break, they walk in the footsteps of Chien-Shiung Wu, the woman who looked into the mirror of nature and declared, "It is not the same." Her life was not just a story of science, but of courage. The courage to question everything, even the laws of reality. When the world speaks of Einstein, Feynman, or Curie, it must also speak of Wu, the woman who made the universe whisper its secrets. She proved that brilliance can be ignored but never erased. And as long as there are minds that dare to ask why, her story will live on, not as a forgotten chapter, but as a shining reminder that sometimes it takes one woman to show the world that even the laws of physics can be wrong.